Welcome to this tutorial on the differences between microphone preamplifiers. Microphone preamplifiers play an important role in the sound recording process and can make a useful contribution to the character of the sound. In this video we will examine the primary design factors that differentiate them and how these factors affect their uses and audible character. A microphone preamplifier performs a simple but essential job. It must amplify the very quiet signal coming from a microphone up to line level so that it can be recorded, processed or sent to a PA or monitoring system. It must do this without distortion and without introducing unwanted artifacts into the signal. The first thing we need to look at when choosing a mic pre are its features. Some mic pre's are minimalist, whilst others are designed to accommodate a wide range of microphone types and recording setups. Here are the primary things that we need to look at. Balanced XLR mic input, a balanced XLR line output, high Z DI instrument input for connecting an electric guitar or bass guitar, send and return insert connections to allow the connection of a compressor or EQ, a gain control to control the input gain, input gain metering. Some mic pre's only have a single LED which changes colour according to the signal level, whilst others will have segmented peak metering or a VU meter. An output level control to attenuate the output level. This is useful if you are driving the input hard in order to add harmonic coloration and need to reduce the output level. A trim control, which may allow fine tuning of either the input gain or output level. Phantom power. A pad switch to reduce the input circuitry sensitivity and prevent input overloads. A polarity reverse switch, which is useful for multi-miking situations. An impedance control to accommodate the needs of different microphone types, especially ribbon mics. Condenser and dynamic mics operate well with an impedance input of between 500 and 8,000 ohms, 2,000 ohms being typical. Changing the impedance can have a subtle effect on the frequency response. Ribbon mics will need something like 20 kiloohms. A dedicated ribbon microphone mode, which will raise the input impedance and disable accidental enabling of phantom power. A high-pass filter to roll off unwanted low frequencies. And finally, the form factor. Do you need the device to be portable, standalone, rack-mountable, or integrated into another device, such as an audio interface? The technical specifications of a mic preamp will give you some indication of the quality of its design and manufacture. The primary things to look out for are frequency response. Unless we have a specific need, we will want this to be as wide and flat as possible. This means at least 20 Hz to 20 kHz with no significant changes at any frequency. We may not always want a flat response and prefer a response that boosts some frequencies, perhaps in order to add clarity or definition, but either way we can check the frequency graph if one is available. Secondly, noise performance. Specifications can contain various confusing statistics on noise and distortion. Most mic pre's perform well or adequately. However, if we plan to record a quiet or delicate sound, we may want to check noise performance audibly. And lastly, dynamic range. An input gain range of between 0 and 60 decibels is typical and should accommodate most situations, especially if a trim control offers another 10 decibels or so of additional gain. In the early years of microphone preamp design, available electronic components made it difficult to process the signal without distorting it in some way. As designs improved, these distortions became more acceptable, even desirable sometimes, adding harmonic colour and enhancing the signal. Today we refer to such designs as vintage or classic, and the sound they produce has been silky and smooth, or having character or warmth. Modern components have advanced to a point where cost-effective, transparent designs are commonplace. Distortions are to all intents and purposes inaudible, and the full character of a microphone is revealed. In fact, the differences are so small that it's hard for even experienced engineers to identify devices in a blind test. It is worth saying that even differences between transparent and character designs can be hard for the untrained ear to detect, and that choice of mic preamp usually has less of an impact on a recording than the choice of mic and its positioning. However, a great many characterful designs are still manufactured, and we therefore have a wide range of choices. There are many components that contribute to giving a mic pre its unique signature sound, but perhaps the two biggest are: 1. The use of valves or tubes in the circuitry, and 2. Transformers on the signal input and output stages. There are two primary ways in which components such as these can affect the signal. Firstly, slew rate. The slew rate is a measure of how fast an amplifier can respond to sudden changes in amplitude, especially those that occur at the transient or attack of a sound. Early designs had slower slew rates which tended to soften or smear transients. This has the effect of making the signal sound more organic and less detailed, and can be useful in minimizing the sound of clicks and pops from things like instruments and saliva. Secondly, harmonic distortion or coloration. Harmonic distortion was originally an unwanted side effect of early electronics, but is now recognized as a useful effect. Even integer multiple harmonics tend to thicken the sound, whilst odd integer multiple harmonics can add some brightness. These effects can be subtle and difficult to achieve with other devices such as EQ and exciters. We're now going to look at three very different microphone preamplifiers and talk about the features and design approaches that differentiate them. The first preamp we have here is the Sound Sculpture MP573. It's a recreation of the classic 1970s Rupert Neve design for the Neve 1073 studio console. It's a much loved device and has been used on countless recordings. It utilises Carnhill transformers on the input and output signal paths, and these, together with a slow slew rate, deliver a smooth sound in which transients are smeared and harmonic colour is added. You can see that it's a very simple design. It's got a gain control and a trim control, a polarity reverse switch and phantom power. It has got a DI instrument input. It has a very flattering sound, but it's not transparent. It definitely adds something to the signal, making it perhaps warmer and more organic sounding. The second device we've got here is the Grace Designs M501. Now, Grace Designs are all about modern, transparent, transformerless designs, and this is a prime example. Again, ergonomically it's very simple. It does have a ribbon mode, which is useful, and an instrument DI, but essentially it's trying to amplify the signal without changing it in any way, adding no coloration, and certainly not trying to smear the transient, so a fast slew rate. And the final design we have here is a Dave Hills design Europa. Now, this is a unique design in that it utilises digital control to allow the slew rate and amount of additional harmonic content to be determined by the user. In fact, you can see here it's got a control for the slew rate, and it also has control for the even and odd harmonics, so you can thicken the sound and make it brighter. So this is a pretty unique device to allow you to get a range of sounds between the extreme of something like the MP573, the Sound Sculpture from the Neve 1073 console, and the very transparent sound of the Grace Designs M501. script for this tutorial with accompanying screenshots can be found at projectstudiohandbook.com. And finally, please don't forget to subscribe to our YouTube channel or at the website to get instant notification of new videos as they are uploaded. And please do click on the ads of interest to you. We're a free resource and they help to pay our costs. Thanks very much for watching.